let's get started.
Yep.
Thanks for coming. Thanks for joining us online. My name is Jakub Zavrel. I'm the founder of Zeta Alpha and co-host of the monthly roundup of trends in AI together with Dinos.
Hi everyone, I'm Dinos. I'm an AI researcher here at Zeta Alpha, and we have an exciting webinar once again. A lot of things happen, so let's get right into it.
We have products.
Yeah.
We have news. We have papers. Is that a product?
Papers?
Which one is the product here?
I would say the this accelerator, AI accelerator, maybe this smiley robot.
And we have new models, lots of them.
A lot of models.
So let's dive right into it, because otherwise we're not going to finish within the hour. Our goal is to read everything, be on social media 24 hours a day, and watch everything on YouTube. So you don't have to, and we keep you informed.
Except for the gossip.
There's a lot of gossip as well, but let's skip most of that. It's too much of it. So let's dive into the news. Just a few days ago, Amazon announced its new Q chatbot, which is basically its answer to Microsoft Copilot. It's kind of a blend of a code generation tool that was known as Code Whisperer, the Kendra search engine for business content, and some kind of personal productivity tools as well. I haven't seen it yet. Have you?
No, but I don't assume that it has to do anything with the Q-Star.
We would skip the gossip, remember? There was an OpenAI.
Yeah.
I think the sort of missing AI strategy is Apple's, right? They fired all their self-driving car teams, or repurposed them to work on large language models. Now apparently they're building up a European lab in Zurich and hiring a lot of people from Google. There were a lot of computer vision lab people in Google Zurich. So I think that has something to do with those Apple plans.
Yeah, and we're expecting an event from them in the coming week and the next month. So I guess they're lining up everything to be ready by then. But at the same time, we see a lot of controversy and
there's hiring, but there's also firing.
Exactly, yeah. And the reason behind that is none other than leaks and kind of industrial espionage. So this is why OpenAI fired a few researchers, and among them, a few high-profile ones are well connected to leading figures like Ilya. So yeah, they found out that somehow they leaked some proprietary...
They published a paper.
I don't think there was that.
Mortal sin.
Yeah, because we do have, spoiler alert, a paper from OpenAI, but I think most of these people are still well standing in it. But also, speaking of this kind of industrial war zone that the AI space has become, Adobe has been caught kind of red-handed with their new Firefly.
How did they figure that out?
I think it was mostly going into the data that it generated, and it resembled a lot of Midjourney images.
Right.
And yeah, you can trace back sometimes if it's something very prominent. So yeah, they've been caught red-handed with using some of these community-sourced images, even though they claim that this tool was ethically trained, that doesn't violate any artist material, which I guess it doesn't on first degree, but then, yeah. At what point does it get to watered down?
I mean, training on synthetic data is all the rage, right? So why wouldn't you? Unless, of course, Midjourney forbids it. I'm not sure.
I think they do, and at least it's like a competitive product. So I don't think they're too happy, and this kind of raises a few copyright issues.
Yeah, there's a lot of fuss about copyright, right? The court cases from the New York Times against OpenAI are still ongoing. A lot of publishers are signing deals with OpenAI and Google to license their content for AI training. It's also part of the European regulation, right? Have heavy emphasis on copyright. But there's more regulation coming. California has its own
Bill, yeah, I think it was proposed a few months ago, and now finally it's in the final stages of being passed. And it reminds me a bit of this one piece that we covered on the Indian regulation. It's not as strict, but there are a few requirements from companies disclaiming what they're going to use the model for, and if they're sure that it doesn't violate some very basic principles, if they have done their homework basically to safeguard it and so on.
It's interesting that they use this concept of frontier models again, right? That is kind of the
new definition,
the flops-based definition of what's needs to be regulated. Well, California certainly would regulate OpenAI, and it's interesting to see that the US is regulating on a state level, because you'll get a lot of different regulations. Maybe in Texas, your chatbot can swear a lot more than in California. And there's also on the national level in the US, regulation has been launched, and one of the measures that Biden's Executive Act does is this AI Safety Board, and apparently it has all the CEOs from big tech on it. It's a board of basically the people who are making the technology. I don't know how.
I think the lobbying took the right way there, but is it really all CEOs?
Well, here we have the list. So Jensen Huang is on there, Satya Nadella, Sundar Pichai, etc., etc. It's basically a list of all the stakeholders in hyping up AI technology and making a lot of money with it. Apparently, Jan LeCun was not invited. And so also, none of these people are behind open source companies. So Jan LeCun got snubbed. Timmy Gebru, famous critic of this kind of regulatory capture, said it's a bit like appointing the foxes to guard the henhouse, and that's mildly put. There's another interesting development in this big tech. We're actually kind of seeing a new browser wars. Basically, both Chrome and Safari are racing to kind of catch up with this somewhat maverick browser company that is producing this Arc browser, which is very nice change of pace in browser technology. And basically now all the big browsers are racing to integrate LLMs and AI directly into the browser.
Although I think Arc, they hired ex-designers from Apple, Tesla, and Google. So I think it's they're trying to catch up with basically their offspring.
With their own innovators that left, yeah. But it's very interesting to think about it. If sort of for personal use, you will have everything in your browser.
It's the perfect exposure room for everything that you basically do. There is information on what you visited, what you like, what you read, what you spend most of the time on. So it makes sense that you would want to bring as many AI features out of a single tab
there, rather than going to a particular website to keep all of your personal stuff. And I think Apple actually has a kind of an edge, because their strategy is privacy first and AI computation at the edge in the device itself. So, and
a lot of pressure of having this one ecosystem that does everything, and you don't have to go to others.
But oops, Apple doesn't actually have any LLMs. That's not to speak of. They published a little bit, but supposedly they are in talks with OpenAI to license their models. What do you think?
I find it a bit hard to believe that all this research, because even more so in the past few months or in the past year, they have been putting out more open research in this MLX library and these new models that we'll see in a bit.
Yeah.
So they are like trying to make a statement that, okay, we're not that far behind.
My guess is they're betting on two horses. They want to have a solid backup plan with OpenAI, but their strategy is actually going to be that the smaller models, which can run on device, are going to be powerful enough very soon.
And also,
and then they'll drop opening.
all of the mobile devices also focus on photography and all those that they already present as AI powered, but now you need to go to the next step where generative features come in, not just to make your photo look prettier.
And to have this kind of assistant that's with you all the time, yeah. So in hardware news, obviously NVIDIA's dominance is being challenged in all kinds of ways. Intel is launching its a new generation, the third of its Gaudi accelerator, which supposedly has a performance 50% over current NVIDIA H100s. It's coming on the market in Q3, so still a little bit of waiting, a little bit more waiting for Rivos, which is developing an entirely new software-first architecture, where they're kind of trying to make sure that PyTorch and everything will run on it, but it will be a new server chip based on RISC-V, which is kind of the open source competitor to ARM.
Mm-hmm. But I have a feeling that $250 million is kind of a change for NVIDIA's gimmicks that all big companies just give out investments into other companies to end up in NVIDIA's pockets. So yeah, obviously we hope.
Well, certainly there's a big desire to have more choice in this space, and Meta, I think, the biggest customer of NVIDIA, right? They bought more than 500,000 H100s this year, but they're also building their own silicon.
Yeah, they're also looking to the future, and how can they make sure that they have both enough compute for training, but also inference, because now they're launching more and more products with their Meta AI line of models. So yeah, you need to have kind of autonomy in the future. Maybe silicon is the new gold, and we're already starting to see that.
Well, this Meta chip apparently has almost 200 gigs of on-chip memory, so you can definitely do inference for very big models. LLaMA3, 400 billion parameters, who knows? So in our category of AI investments, there are some big numbers, but it's actually been kind of a slow month. Some of these sort of multi-billion investment have slowed down a little bit. I think there's a bit of afterburn when inflection imploded, and yeah, it's a risky world. So we've seen Microsoft invest in G42 in the Emirates. I think a lot of that is going to go to NVIDIA to build a local Emirati supercomputer. We see NVIDIA acquiring Run.ai, and we see even companies coming onto the market with very high investments, like, for example, Augment, which is a coding co-pilot.
Yeah, hopping on the hype train of Devin, I guess, which started a few months ago.
Exactly. Yeah, I think Devin is also raising money, but it has not been confirmed. There's a lot of gossip also about Elon Musk raising a lot of money. For sure, CoreWeave, one of the hardware vendors, has raised $1 billion. It's kind of NVIDIA financing their own customers, I think. But it's not always successful. In fact, Stability laid off 10% of its staff because it was running short on cash. And in that process, it's been revealed that they were spending 100 million on GPU just to get about 11 million in revenue. They're very popular.
It is a trade-off, though, because they also kind of give back to the community. So it's no secret that you need a lot of compute to produce models that take the leaderboard across many places, like image generation, video, audio, and of course language models.
And we see many countries like the Emirates, but also Canada, going for this sort of sovereignty, autonomy of AI, R&D, and infrastructure. I love how Joshua Benjo is sitting on Trudeau's shoulder there, like a little evil genius. um, right? Robotics.
Yeah, and I think as we predicted in our in the January episode that robotics is going to have its moment finally this year, and I think a few news articles are starting to reflect that. We all know Boston Dynamics has been around for a bunch of years in the kind of forefront of robotic capabilities
In
and
making really cool video clips,
really cool video
especially.
clips. Yeah, humanoid
Isn't that
robots,
their
but
like
also
main line of business, making video clips?
humanoid robots, also animal-like robots,
Yeah.
and recently they revealed their kind of new design for Atlas, which is their humanoid version. That video was a bit spooky because it started with the robot being completely on the floor and then in a very unorthodox way stood up in a way that no human would. But maybe this just signifies a new era of capabilities and ways that the models are going to interact with the environment.
It was a nice video clip, absolutely. Yeah.
And also we have investments closing in the robotics field, which, as expected, it's in a very high 100 million ballpark. What do you think this means for the whole field? Is it only?
I have no idea. It's a very secretive startup, so we don't know what they're doing.
Is it gonna follow up with more companies, or is it the good few that get endorsements from OpenAI and other kind of pioneers in the AI field?
Well, I think the big difference between this year and last year is that it's really easy for robotics companies to basically tack onto the large multimodal models. So to basically implant a brain in the machinery without a lot of effort for perception, so vision and language and even action control. And how you translate that to like real, well-functioning robots on the hardware level, that is still a bit of a puzzle. There are models being trained which are multi-embodiment, but I think that's not quite there yet. But the large multimodal models are completely capable of giving the humanoid robots at least a very good demo experience during filming of video clips. I don't know.
Yeah, maybe you
would
don't
you get one in your home?
Not currently, but I mean,
not yet.
if you just restrict it to application, you don't have to have a generalist robot, and you put it in a very specific environment where you can pre-program some interactions. Then I think we're about to see some very cool products being launched.
You have a bit more on that with
Right.
LLaMA.
Yeah,
right?
we also covered this a few months ago, and there was this kind of controversy that this was kind of teleoperated or it's not exactly as it seems. Well, now they have come out with a new version, which again, they don't go too kind of ahead of their own pace and saying, oh, we can do a bunch of things that no other robot can do. But for simple tasks like folding clothes and tying up shoes, I think they're just experimenting with how dexterity can be evolved in robots that are not too costly. Because I think the Mobileye paper was about how can you bring the cost down while keeping a high kind of capabilities.
So what are we seeing here in this video?
Yeah, I think it's a robot that's fully autonomous and
fully autonomous tying its shoes. Well, that's progress for you. Or is it teleoperated secretly?
No, I think this one this is why they came forward with. Otherwise, it would be the same level of capabilities as before.
Oh, that's pretty cool. I also saw one for folding t-shirts. So all the stuff that geeks don't like to do will be done by robots. And we have another kind of robots, the ones with 4 wheels. And this was really surprising for me. Mercedes is the first automaker to have a license to sell cars in the US that don't come with this sort of disclaimer.
I think Elon must be devastated about this.
He must be livid.
Yeah, because this is quite some landmark for autonomous vehicles. I think a lot of them hope to be at a point where you can say this is truly self-driving, and yeah, many cars that are now being launched from classical automotive businesses like Ford, Mercedes, and all those people But yeah, I think this also has to do with the fact that, as you said, for robotics in general, you're getting more and more capabilities kind of for free if you just have a language model that can process stuff.
Which is the case with Lingo, right? Lingo is from Wayve. It's still not selling actual systems, but it's developing very rapidly. And it's a model which has full sensors and cameras, and you can talk to it, basically. You can ask questions about the environment and everything. It's a end-to-end trained multimodal and action model, right?
Which I think is on the same path that Tesla is following, that you just need a lot of compute and a lot of real world videos that just show them the car how to drive itself, basically.
But so far, the real winner is just the chip makers again, with Mobileye, who is selling 46 million of their perceptual chips for regular cars, for things like parking or lane assistance. Pretty good. All right, so open source had its launch day this month, right? With LLaMA3.
Yeah, and I think everyone on the internet went crazy about it, and rightfully so. It's a very capable model. It's been now, I think, 2 weeks or a bit less than 2 weeks, and you already see a lot of people saying, okay, scrap everything you had before. You can just take this one model or two models, because they released an 8 billion version and a 70 billion model. And they seem to be quite competitive.
Can you just briefly summarize what is LLaMA3? How is it different than LLaMA2?
I think it's just pre-training and tokens that is seen. It is, I remember,
the amount of compute that was
amount of compute, basically. Yeah, it's pretty much the same architecture. I guess a bit bigger, because usually they ship the smallest one in 7 billion parameters. But the main point that they try to make is that we have a very large collection of internet data. So they say it's all publicly available internet data. I don't know how publicly available it is, but they're claiming that it's not something very unique to their reach. And obviously no user content from their own platforms, because that would spark some revolts. And if I remember correctly, they said that these models were trained on 15 trillion tokens, as compared to 2 trillion on...
Right, so an order of magnitude more tokens and compute. And how does it stack up? Is it really that good?
Yeah, as we can see here in these figures, this is, I think, for the instruct tune model. So adding a bit more steerability to the model through instructions and through examples of actual tasks that these modules are usually benchmarked on. We see that it's very performant on MLU, even for the 8 billion model. It beats both Gemma, which is the open source model from Google, and Mistral 7B, which by now is a bit old news, but they definitely prove that they can catch up and produce a model that people can use. And then when we go to the 70 billion model, we see actual models that people have in their mind that this is the state of the art, such as Gemini Pro 1.5 and Claude 3 Sonnet. As you can see, there is no mention of Claude Opus or GPT4, but there is a reason for that. The model, Meta said that they're still training a bigger model. And how many parameters would that be? Can you take a guess?
I read it in the notes. So it's a little bit more than 8 billion.
So it's 400 billion.
50 times more.
And this is kind of, again, reaching a point where most people won't be able to run it themselves.
And this is not a mixture of expert model like some of the other ones, right?
I'm not sure if they said something for the 400 billion. These two are, but I don't remember exactly if they said for the 400 billion. And they just showcased what they currently have, like the checkpoint that they're still in training, what the capabilities are.
That's this here, right?
Yeah, so they only put out the numbers for their own model, and obviously the community said, okay, how does it stack up? And it actually stands up with many models that people thought, okay, Claude 3 and GPT4, surely Meta doesn't have the technical know-how or the data that you need. But I guess, no, that's not true. There's still a kind of a point of discussion. Are they going to open source this one? Or is it just going to be the point where Mark Zuckerberg said, okay, if it stops being viable for us as a business, we'll stop open sourcing. It's not like we are the open source.
If you don't invite us to the AI oversight board, then
we won't
make it open. Or then the other way around. I don't know. Maybe it's a threat. So how open is LLaMA3?
It has the same license as LLaMA2. So in terms of where you can use it, it's for companies with a very specific number of monthly users, which is
very high,
just a bit lower than the top 2 or 3 companies in the world. The data is not open. It's just it is publicly sourced, but
so the weights are open, the code is open, the data is not open.
Code only for inference, not for training.
Right.
Yeah. So it's in the same kind of ballpark of openness that Mistral has made us very familiar with.
Great. So what I like is that the open source community has really jumped at this. So it's just been around for about 2 weeks, and there are already all these different fine-tunings of it. So people have extended its context to 128,000 tokens, I think even more. So another one with LLaMA Giraffe and News. I never know how to pronounce it. Nous research. Is it Nous or Nous?
In Greek, it would be Nous. Yeah.
Nous. Since Hermes is a Greek character, it must be that. Did this other fine-tuning, which is even more capable than Instruct, and we'll see a few more fine-tunings.
But I think we're starting to see kind of the limit of how strong can a base model be versus its fine-tunes, because, for example, the Nous fine-tunes of LLaMA 1 and 2
differences are not so big as
so obviously when you have such a strong model, I mean, Meta themselves have put a lot of effort into making it as good as it can be out of the box. So Nous were able to get it even a bit more better.
So we'll come back to this in a bit, but there's a lot of other model releases there. Let's rush through them a little bit. So we have Mistral. So it's already kind of old news, right?
Yeah, but what we see here is kind of this new characteristic plot where you have on one axis the active parameters and on the other some kind of benchmark. On Mistral it was MMLU, and they launched this with their new mixture of experts model, 8 times 22 billion this time, which kind of lands on this Pareto.
I read some other paper that Mistral is actually completely fitted to MMLU.
Well, they still are very viable models, like people use them in production environments. So I think maybe there's some benchmark hacking, but still the model is pretty good. And on the same kind of graph, we have a new model called Snowflake Arctic from the Snowflake DB guys.
Yeah, I think they are competing mainly with Databricks, right?
Yeah, and if you pay close attention to this graph, this y-axis is not MMLU now, but it's enterprise intelligence.
Whatever that may be, in percentage.
Yes, and I think this the datasets that they use for this is kind of more SQL generation or tool use, stuff like.
Yeah, well, Snowflake is a database, so that would make sense, right? So Reka, also pretty competitive model. It's a multimodal model, right?
Yeah, the Reka Core model is
Yitai and his band of pirates.
A very competitive model, actually. It lands right next to Cloud 4 Opus, GPT4 Vision, and Gemini Pro or Ultra.
Language or only in multimodal stuff?
No, I think they benchmark them on a bunch. So there's MLU on the top. There's also MMU and all kinds of other tasks, coding generation, VQA.
Yeah, so
very competitive model.
And then we have very small models.
Exactly.
Like 5.3.
Yeah, this model is basically trained with distillation from GPT4 outputs. So this is coming from Microsoft. So they have all the resources to generate data with GPT, and
they basically generate high quality synthetic data here, right?
Exactly. Yeah, and they I think P2 came up until 3 billion parameters, and now they're scaling it even more. I think they released only the small ones, which is mini 4K, mini 128K, which is under 1 billion, but then you also have small and medium under preview. Which kind of stuck up on average with similar size models. It's not like it's a clear winner.
And 5.3 is open as well, right?
Only the smaller ones. They haven't opened. They haven't published the kind of bigger ones that are competitive with Mistral.
And then we have this little joke, which is not available, but it was available for
exactly. Yeah. This is it kind of took Twitter by storm on release. It was a very competitive model. We see it being even above GPT-4 or Cloud 2 on some benchmarks like MT Bench. There's mixture of experts or dense models were right up there. Some people were lucky enough to get the model, but after
it was completely open weight.
Yes. But unfortunately, after a few hours, the model was no longer there.
Sorry for that.
And they claimed that it was due to an oversight in safety training and safety evaluation. This has been, I think, 2 weeks now, and we haven't heard from them yet. And I think we have to say that WizardLM is from Microsoft, so maybe there was some overstepping of do we release this now or not? Yeah, so let's go back to truly open source models, and we actually have a few. First of all, we have Pile T5, which is kind of a retraining of T5 with the Pile and LLaMA tokenizer.
Yeah, so it's like truly a retro model.
I don't think it's that much better than T5 itself, but I think it's like the benefits come from its more up-to-date knowledge and the tokenizer. We have what we discussed about Apple. This is also their debut with an open model, and they went all out with it. But it's not just weights or inference, it's actually the whole thing, like Pythia and Olmo. They have the code, training data, a lot of insights about their training and so on a model, which is again not too much too competitive since like Olmo and Pythia that they're comparing against.
So how is the stock of Apple doing? Oh no, that's a different model. That's the Hugging Face multi-model model, right?
Yeah, it's an 8B, it's a version 2, so the fix 2. It's kind of a vision language model that you can ask questions on images. Pretty cool if you want to use something local, because I think its competitor is Lava, which is a fine-tune of LLaMA.
Yeah, now I'm wondering whether it's looking at the numbers or at the graph, but that's a different story. And the last one that we want to mention is the Jamba Instruct, right?
Yeah, this one came out just yesterday, so we had to sneak in a screenshot. This is a model that we discussed about the fundamental. The paper is a mixture of a Mamba
models, right?
Mamba and a transformer. So is the transformer dead yet or not? So I'm not sure, but it's still a very performant model. We see it against LLaMA and Mistral.
Yeah. All right, I think we'll kind of skip this because I think what GPT is doing is just flooding the zone on the ARENA benchmark. Half of the entries in the benchmark are different variants of GPT-4. That's not entirely fair, but what you can see is that LLaMA3 is in the top 10, and the only an open model. Well, Cohere Command R+ is also open for research, right? And there's a new leaderboard from Berkeley,
which is for function calling or tool use. Basically, you can get any model and benchmark how well it does on following a specific format in the output. So usually this is JSON mode, or specifying a few functions that the model can use and then seeing if it's called them correctly with all the parameters that you specify. But which is cool because now you can see there's this gorilla fine tune of I think LLaMA that you can, or Mistral that you can use if you don't want to go with.
Where is Snowflake with its SQL calling?
Don't see it on the top 5.
Maybe they didn't enter it. And there was this little piece of mystery. There was all of a sudden a GPT-2 chatbot on the ARENA leaderboard, but it disappeared again, right?
No, I think it's still on the leaderboard, but it's no longer getting votes in because this was probably some experiment by OpenAI, although they have not come forward and say that this was truly us. There were some cryptic tweets by some saying, "Oh, I love GPT-2." But we'll see soon, I guess, what this was.
So that's more in the gossip category. Of course, we're at Zeta Alpha very interested in neural search, in vector embeddings and retrieval augmented generation in particular. So a couple of developments in this space that are notable. Basically, everybody has vector search integrated nowadays, even the good old Oracle. Can you imagine? So Oracle database now also supports embedding search, which
I'm looking forward to the promo message, 3 billion devices run RAG.
Then on the MTAP leaderboard, the Salesforce fine-tuned model is on top of the leaderboard for a while, been on top of the leaderboard for a while without actually disclosing how they trained it. Now the blog is out with all the details. It's nice to read, but essentially it's a case of leaderboard hacking, right?
They do have a few good insights on the research side, like how they deal with negatives and how they deal, like they have, I think, a few scaling observations on how many negatives do you need or how do you create those negatives? Do you need many
But
models?
basically, they took all the data sets that are in the benchmark and trained a lot on them. What I also really liked, there's a new paper out, we'll be discussing it in a bit, LLM2VAC, which takes a generative model and turns it into an embedding generation model. And immediately somebody applied it to LLaMA3. So it's very nice. And it's a bit old news, but it was from Contextual AI, which we're following. They introduced a RAG 2.0. That's like the new generation of RAG. But it turns out it's just end-to-end trained retrieval and generation with numeric embeddings in the middle, which is actually RAG 1.0, as it was originally coined in, I think, 2019 by DUQGen, among others, and now rebranded as RAG 2.0. So
sounds fancier.
Sounds fancier. Actually, what everybody's doing nowadays, that's RAG 2.0, and this is RAG 1.0. One of the other developments in the space is this trend towards more efficient embeddings, so binary embeddings, dense vectors that can very easily be quantized into zeros and ones. And we did an interview with one of the research groups in this space, Mixed Bread from Berlin, and you can watch the interview on YouTube.
The interview has a very nice hint on what Mixed Bread is. What does that name mean? But I won't give any more information.
You have to watch the interview. In more local models, there's a variant of Phi3. No, it's Phi2 actually, fine-tuned for Dutch. Yay! Fientje, very sweet name. Pretty good, from Bram van Rooij, from the University of Leuven, if I'm not mistaken. He keeps chugging out all these cool fine-tuned Dutch models, while the Dutch academic and bureaucratic cadres are having meetings about what will be GPT-NL. But I heard informally that GPT-NL is not expected until the end of the year, and it will actually be a lot worse than all existing models. So help. All right, so there's another piece of news that OpenAI is launching a search engine next week to compete with Google. Well, good thing is you can already use Zeta Alpha to search the web and your own data today, so no need to wait for that. We have built over the past couple of years the Zeta Alpha discovery platform for AI papers, which we're using heavily to power the aggregation of news and research papers for this show, but which you can also use to search and do question answering on your own information internally, but also on the web. So no need to wait for search from ChatGPT. And the star of our underlying technology is, of course, retrieval augmented generation, which allows you to answer questions from your own data. And of course, retrieval augmented generation has been prototyped in almost every company using all kinds of tools. There's a lot of open source tools out there, LangChain, LLaMA Index, Haystack, DSPy, very popular recently. And those are great prototyping tools. So what if you want to do prototyping 5 lines of code, right, to build a RAG agent with LangChain, or you have a very complex RAG agent, for example, here from Anthropic, a very sophisticated RAG agent which reads financial reports, interprets tabular data, makes aggregates numbers from different parts of the report, and then answers questions about that. Great in the notebook, very nice for prototyping. So we've been thinking at Zeta Alpha about how to bring these prototypes into production, and we are still work in progress, but we are finalizing this RAG Agents SDK, where you can basically do exactly what you did before, do prototyping of RAG agents in your open source environment with a local user interface and just some vector search engine behind it. But then you can replace that vector search engine with a Zeta Alpha search engine, which happens to be connected into your IT infrastructure with updates and access rights and a single sign-on and all of that. And then once you're ready with developing and you have tested it in your local user interface, you can seamlessly deploy into your production environment where your actual data with all its production characteristics is stored. So we're excited about that. Because behind that is all this infrastructure of actually syncing with all your applications and having different search strategies and fine-tuned embeddings and all that. So that was a little pitch for what we do. Back to the academic research. Switching to the academic research. Next week, in Vienna.
One of the two conferences this year in Vienna, it's ICLR.
And ICML is going to be there as well, but ICLR has finally left New Orleans and pitched their camp in Vienna next week, one of the leading neural network conferences in the world. More than 2,000 accepted papers, 20 workshops, and you can check out the papers in Zeta Alpha.
Yeah, there are a bunch of oral papers and spotlight papers, so we just went through them and found the ones that are mostly relevant to us. But we have
aren't conferences kind of old news these days?
I mean, if you have this webinar, I don't know what you need the conferences for. Maybe just to dive deeper or meet connections and learn what people are working behind the scenes and not.
So the submission deadline of ICLR, to be fair, was somewhere in September last year. So these are papers from about
a year,
9 months old. So but they're filtered through peer review and very high quality. So it's kind of a best of 2023, right?
Yeah, so we have this self-RAG paper, which we covered. And then there are, if you remember 6 or 9 months ago, what the trend was autonomous agents and tool use. So if you see the few more papers, it's about using agents to interact with computers and create programs, using multiple agents together, creating tools and using tools with agents. And of course, the hype of the past few months.
This was ahead of its time because it's actually predating Devin, the human.
Maybe Devin was
the software engineer.
Yeah. And this
model merging, very hip. Yeah, that was ahead of its time.
Yes. Yeah.
Long LoRa. Well, a lot of hits that you have heard about.
Yeah, and a few papers here from the University of Amsterdam.
Pretty solid representation there from University of Amsterdam. You can browse and explore the whole collection in Zeta Alpha. I think that's the QR code, correct?
Yep.
Snap the QR code and go into Zeta Alpha to explore ICLR or go to Vienna next week. Those are papers from September last year. What's everybody working on now?
Well, you know the 3 layers that people have been working on in the past year. So let's skip that and go to the other regions of the map that are not language related. We have, for example, medical imaging, which also pops up quite a lot, and people are very excited to work on. Robotics, privacy and security, agents. I think also one of the few times where retrieval and recommendation systems comes up as a separate cluster.
Yeah, I think that's because the SIG-IR papers were announced this month, and SIG-IR is in July in Washington, D.C., and now the papers are on the web. The anonymity period is over. So let's dive into our selection. It's somewhat focused on retrieval and LLMs. And the first one is a combination of the two.
All right, so our first paper, as we teased before, is LLM to VEC. This paper claims that it's converting, that actually all language models are secretly text encoders. So,
all generative language models, right?
So what the paper proposes is you can transform any decoder-only language model into an embedding generator, an embedding model. And they use this very simple pipeline of 3 steps. Yeah. One is to enable bidirectional attention, because decoder-only models usually have this causal mask where you can only look in the previous tokens, but for embedding, usually you benefit from actually looking both ways. Then the next step is to kind of mix the 2 training regimes, or BERT would be trained with this mask language modeling, and the decoder-only LLMs do this next token prediction. So they come up with a new kind of way of doing both at the same time. And then there's the trick that gets all encoders at the state-of-the-art level. It's unsupervised contrastive pretraining. And just by following these 3 steps on any language model that follows this decoder-only paradigm, you can convert it into a very competitive model.
So basically you take a GPT model, you open up the lid, and you make it into a BERT model.
Exactly.
And then you're done, right? Ayato, as the Czechs say.
And I guess one of the tricks that they don't explicitly cite as a key factor is having the right data to fine-tune on. So also they do it both on an unsupervised way, where they only do this very generic web-level data on Wikipedia, and they get the kind of corresponding state-of-the-art there. But I think the more interesting part is if you actually have the retrieval data, such as the E5 data or the...
Yeah, I think they're leaning heavily on the E5 corpus here, right?
Yeah, but interestingly enough, Mistral 7B, which although before this fine-tuning was not as performant, after they do this, you get close to state-of-the-art. So I think this is on the same ballpark where E5 Mistral is. So yeah, it's another way of converting every model to an embedding model. On their GitHub repo, because this is all open source, they claim that it's very cheap to do this because this is a lot of LoRa fine-tuning involved. So you can do this, I think, in under a day for any 7B model.
Yeah.
And as we said before, yeah, LLaMA3 came out, so people did try it.
Do you have that here?
Yes, in the next, yeah. So in the paper itself, because the paper came before LLaMA3B, 3.8B, they only had these 3 plots, but the developers themselves, they said, so they published on Twitter, hey, we can apply this new easy method again on LLaMA. And yeah, it's, I think, a bit better than Mistral, which is not surprising since the base model, again, is a bit better.
A bit hard to see here, but I think it's just the first step of actually turning the LLaMA model, 3 models into good embeddings. Turns out you don't need to do any of this. So Jimmy Lin, and as always creative from the University of Waterloo with a couple of colleagues, has shown that you can actually kind of do the same, but without any training, right?
Just
you can
from the knowledge of the language model itself.
So you can just take a generative language model and prompt it in a very specific way. And what Jimmy Lin says, I found this under, wait, this works? It shouldn't work, but it does. And what they do is use this prompt. You are an AI assistant that can understand human language. Here's a passage. There you paste the whole text. Use one most important word to represent the passage in the retrieval task. Make sure your word is in lowercase. The word is, and then at that moment, you take a snapshot of the logits in the output layer of the network. Yeah, and that, of course, is kind of a good representation of words that describe the document. And that's what they call the sparse embedding. And to generate a dense embedding, they read off the latent representation in the last hidden state at the same moment. So it's also very efficient because you only need to do one pass and no training. A miracle.
I find this a very interesting prompt, and I am curious how they reached that point where they said, okay, let's try this.
Or is there even a better prompt? But it makes sense. And there's evaluation. and it actually is pretty competitive. So here you see a lot of columns. So basically you want to look at this column here, LLaMA3, 8 billion instruct. It's not as good as BM25, just and the dense and the sparse. But if you combine them, if you do a hybrid retrieval between these easy to get dense and sparse embeddings, you get 44 on beer, which is almost as good as E5. But it has to be said that this is unsupervised. So we just mentioned LLM2 VEC, which gets about 56 when you fine tune it
on beer.
But here it's compared to the unsupervised version. So it's kind of a more academic trick still, because you would have to add that additional retrieval fine tuning. All right, one more embedding fine-tuning paper.
Yeah, and this one has a cool name. It's called DUQGen. The premise of this paper is to...
I don't know what people find cool about ducks, but...
if it has an emoji in the name, I think people will find some reason to
It's not a parrot, it's a duck, it's safe. Yeah.
Yeah, so the premise of this is that you want to fine-tune a model on a new domain, and that you want to do it as efficiently as possible so that you don't unluckily overfit to one part of the domain. So what they propose to do is to cluster the documents in the corpus, and then sampling from those new clusters basically subdomains to generate queries that cover all of the domain, or at least the ones that you are aware of when you do the fine-tuning.
Yeah, so it's kind of a follow-up on InParse and PromptReps, which generates synthetic data to fine-tune embeddings.
Yeah, they claim that this is a lot more sample efficient. So with just 1,000 samples or 5,000, or either Colbert or Mono T5, they're able to get very competitive performance with PromptReps on most of the beer datasets. I think importantly, what they show in the results is that compared to previous generation methods like InParse and DUQGen, they do not regress on any of the data sets. So on each of them, you see an improvement over not fine-tuning either of the retriever or re-ranker model.
Yeah, but that's kind of because the prompting is specialized for every task in beer, right? Like they have a different prompt for every task. So that's kind of the reason for not regressing, just like PromptReps. So what?
Yeah, this is just showing that they check how many clusters do we need to generate, or how many training data do we need, and they find kind of this optimal at 1,000 clusters and 1,000 training data for the fine tuning.
Right. All right, DUQGen, check it out. This is a very cool paper which came out just last week, I think, from Meta. Better and faster large language models with multi-token prediction. So what is this about? Well, basically, these generative large language models, they always predicting one next word. And what they're doing here in this paper is simply adding multiple output heads and training them to predict a kind of n-gram of multiple next words. And that turns out to be better than training only on the next word. And the interesting thing is that you don't really notice that when you're training smaller models. So this is an effect which only becomes apparent at scale. So from 3 billion, 7 billion models onwards, this gives a really strong advantage over just training for the next word. So basically, it's kind of a shared trunk. It's a normal transformer model. Then on top of that, a multiple number of output heads. And they have this clever trick here, how you can avoid blowing up the gradient computation in for training the model by just kind of doing one backward pass per head at the time. And of course, it's great that it's better in terms of quality, but it also potentially a lot faster. because you can do all of these calculations at the same time. So you can do kind of speculative decoding, generate a number of tokens at the same time in parallel. And they find that predicting 4 tokens at a time is the optimum, which is interesting. Why does it degrade after that? Probably has something to do with the amount of training data. So that's, I think, a very cool innovation, which will probably be adopted very quickly.
But not for the GPT-4.
Well, I think 7 billion is the standard for the GPU-4 these days. The next paper is more about evaluation from Cohere. So I think they were very frustrated at Cohere that when this is new trend, right? Having the output of LLMs be evaluated by other LLMs. And of course, you don't want to just get some guy to evaluate your model. You choose the most powerful on GPT4. And at Cohere, they were probably a little bit beefed that GPT4 is not really evaluating Cohere's models very well. No, that's not the real reason. So the idea here is that instead of having one very expensive model as the judge of LLM output, you can get multiple, like in an ensemble system, you can get multiple weaker models to produce evaluation and then pull them together as a panel. So the system is called POL, for Panel of LLM Evaluators, and basically just averaging over the different votes. So you take faster and cheaper models like GPT 3.5 or Haiku, and you pull them together. And it turns out that this is reduces variance and produces judgments which are more aligned with humans, simply said. And it's also a lot less expensive because these models are an order of magnitude cheaper and faster. And here in this graph, they kind of prove that on Chatbot Arena, it produces, the poll system is the orange one, that it produces more consistent rankings than GPT-4 as a judge. And here you see that I was not that off. So actually GPT-4 as a judge discriminates against Command R plus and against Command R from Cohere. So,
but I think this is also because the Cohere people said that they put a lot of emphasis on not training on GPT data, and we know that GPT prefers its own data.
Yeah, so you also have that a little bit. One other little quirk here is that this poll system, which apparently aligns with human judgment, prefers Mistral medium over Mistral large. So I don't know if that's revealing something, but it's interesting. Interesting method. We'll probably build it into our Regilo toolkit. So this is a paper about also doing something very much without fine-tuning and training, right?
Yeah, I mean, in-context learning has been seen as this kind of fine-tuning at inference time. So Google DeepMind with their Gemini 1.5 Pro model, where it boasts 1 million tokens as input, I think. So they're trying to find, can we actually benefit from all these tokens at the input level? We all are familiar with this few-shot learning paradigm, which is 1 to 3 to 5 examples. Now they say, okay, let's scale to 200, 500, 5,000 even. And they find that for some tasks, it does bring benefits. I think in most tasks, the more you go, the more examples you fit in the prompt, the better performance gets. There are a few counterexamples, but in general, it does improve performance. One of the methods that they also propose in this paper is how do you fill this context window? Because you don't always have 5,000 examples from your domain. So they come up with methods to generate synthetic chain of thought rationales, or even just put the input examples from your domain, but no output pairs. And that it turns out that it also helps with performance.
Longer contexts lead the way to better in-context learning. And we have a lot of papers on longer context this month.
Yeah, just as a
we're gonna run through them very quickly because we're almost at time.
As a quick summary, because they're also not too innovative. We've seen many papers doing kind of chunking of the input and using some recurrent mechanism.
So do we now have infinite context?
Exactly. Yeah, this is what this paper claims, leave no context behind. The main idea behind it is to chunk your input into segments, and then you have local attention within each segment, and then across the past segments, you kind of have a compression of the memory that you look back into and update dynamically based on what you have currently. Yeah, and then benchmarked on long context language modeling, passkey retrieval, and book summarization. This method seems to work a bit better than existing approaches like transformers or recurrent memory transformers.
So infinite context, this is not entirely the same. It's not really a transformer. Megalodon is a kind of approach to resurrect the LSTM from its grave, building a very specialized kind of gating mechanism that keeps track of the context over infinite length. And we also have LongEmbed, which applies this sort of long context trickery to building embeddings, right? Embeddings of 512 tokens are still a bit the norm, but that's a bit short for kind of realistic chunks. So you want to extend it to a few thousand, and this paper shows the way how to do that with existing models by just replacing the position encoding methods. Yeah, this paper really does deserve a few minutes.
And it's a surprising entry because it's actually a published paper from OpenAI, which is not too secretive about what they did.
Were they fired?
I think most people are still there. It's called the instruction hierarchy. Basically, they're making an observation that in a prompt or in a conversation, you have different levels of privilege levels.
Yeah.
The system prompt is the most important one. Then you have the user that might say something that should steer the model when he's allowed to. And then you have lower level information levels like the model output itself, or even tool use that externally fetches some information.
Yeah.
So,
or hackers trying to prompt inject.
Yeah, there are a lot of attacks that we've seen in the past year where GPT popularized, and yeah, they synthetically generate these examples to train a model to not obey lower instructions placed in the lower level of the conversation.
And are these like different colors of tokens in some sense that are different?
No, I think they treat the whole level as one priority.
Yeah.
Yeah, and they show that this method does improve resistance to these attacks, especially this system message extraction, which many companies now have built their mode around having a very good system message that will basically do most of the functionality in the platform.
So there are some examples of how that works. We have two papers to wrap up. Chinchilla Scaling, a replication attempt, has caused a lot of stir on the social media. You might remember that in 2022, the Chinchilla paper kind of changed the way scaling laws were formulated and showed that then current models were severely undertrained. So people started scaling with very much higher numbers of tokens. In fact, the Chinchilla paper proposed kind of formula for the number of tokens per parameter that you need. And this study shows that the science behind it was kind of wacky. And that extrapolating from exactly the same data that DeepMind used in their Chinchilla paper, they arrive at completely different parameters to fit this data. And in fact, this green line, which was in the Chinchilla paper, turns out to be better modeled by this, or the data turns out to be better modeled by this blue line, which is going in the other direction. So if you're interested in scaling laws, definitely worth reading. And I've not seen anybody debunk this paper yet, so I think it stands. And the last one is about from Stability AI, or should we say Instability AI, about their music generation.
Yeah, I think it's an open source report on stable audio too, and they kind of show that, yeah, as you'd expect, this is a diffusion transformer, and there's 3 components to it. Surprisingly, it's not that big of a model. It's just 1 billion parameters. And most of them go to the diffusion transformers, the autoencoder, and the embedding model, just a few 100 million parameters. And they show that their main focus is consistency on the long form generation, so up to 3.5 minutes.
Basically the hit song, right?
And they focus a lot on kind of abstract and background music, unlike the other tools we showcased last episode with
Suna AI. Yeah, that was very decent. All right, so a lot of code, Karpathy doing crazy stuff in C, and LLaMA3, of course, and lots of other cool stuff on GitHub. And we leave you for the weekend with a nice theoretical read.
It's the transformer, it's the MLP replacements.
Multi-layer perceptrons are over, apparently. We're doing it all wrong. Do you want to explain the general
The
idea?
very high level idea is that you don't have a fixed activation function, but you have to learn it per weight.
Per weight.
Yeah.
Oh, that's good news for NVIDIA. All right. So thank you for joining us online and here in person. There's a lot of events coming. ICLR, Open SearchCon, where we're presenting the European Summer School on Information Retrieval, ICML also soon, and SIG-IR. Our next event is going to be not here in Lab 42, but across the road in Startup Village, co-located with a Google event there. And we're looking forward to see you there. If you want to catch up with the papers that we discussed in this edition, you can find them here under this list, this collection in Zeta Alpha. So we wish you a good weekend and enjoy discovery.